This lesson can be utilized if you missed class on Monday, January the 27th in first or fourth block, 8th grade math. To begin, go ahead and copy down this warm-up or print it off from my assignments page or from the calendar, and I'll go over it in one moment. Now that you've had a chance to look at the problems and solve them, and if you haven't, please make sure to pause it now and do so. Let's go ahead and go over the way to do them. So the first step in the first and second problem is to go ahead and label which parts are A, B, and C. C is always a hypotenuse that is across from the right angle, so we let that be C. A and B can be either leg, but we usually let A be the short leg and B be the long leg. So we can go ahead and label the other triangle. In the other triangle, across from the hypotenuse, C is the longest, A is the short, B is the long leg. Now the legs are what make up the right angle, and the hypotenuse is what's across from the right angle. So let's go ahead and look at the work for both of these problems. In the first one, we let A be 16 and B be the long leg. So if A is 16 and B is the long leg, we say 16 squared plus B squared is equal to 34 squared. So on the calculator, we can go ahead and do 16 squared. We get 256, and 34 squared, we get 1156. So we know that 256 plus B squared is going to be 1156. All I did was 16 squared in the calculator and 34 squared in the calculator. And then I subtract 256 from both sides. I'm left with B squared on the left side. And then we do 1156 minus 256 in the calculator. That gives us 900. So B squared equals 900. From there, we take the square root of both sides. The square root of 900 is 30. So the length of B is 30. Our perimeter is just all of the side lengths added up, A plus B plus C. So we take 30 plus 16 plus 34, and that gives us 80 inches. And then the area of a triangle is 1/2 base times height. So we take 1/2 times 30. The base right here is 30 inches long, and then the height is 16. 1/2 times 30 times 16 is 240 inches squared, or square inches. We do the exact same work for the second problem. I'm going to go ahead and pause it, and you should too, so that you can have some time to copy down the second problem. Now, moving right along to the third and fourth problem. The first step, just like before, is to label the sides of the triangles. We look at the side that is opposite the right angle, and that's going to be our hypotenuse. C is always our hypotenuse. Then the other legs can be A or B. We like to let the shorter leg be A and the longer leg be B. So 20 is shorter than 21. The short leg is 20. The long leg is 21. You're going to do the same exact steps as before. So I'm going to go ahead and label the other one. Across from my hypotenuse, across from my right angle is my hypotenuse. So we have C is 50 yards. And then I look at my other sides. It's pretty clear to see that this leg is much shorter than this leg. So I let this one be A and this one be B. So in the first problem, number 3, we are solving for C. C is the missing piece. The hypotenuse is missing. And in number 4, we're solving for B. So I'm going to go ahead and show you the work for that. In both problems, we have A squared plus B squared equals C squared. We plug in the parts that we have, and we solve for the missing pieces. Then once we find A, B, and C, we add them all together to find the perimeter, and we use 1/2 base times height. So once you've added them all together to find the perimeter, then you look at the first one. Our base is 20. Our height is 21. So that's where we get our 1/2 times 20 times 21. And our base here is b, which we solved to be 48. And our height here is 14. So it's 1/2 times 48 times 14 is where we get that one. In the next problem, number 1, part 2, it says to find the hypotenuse, area, and perimeter, which is the same thing we were doing in the previous 1 through 4, of a right triangle with legs measuring 22 inches and 120 inches. So if it tells me what the legs are measuring, and I know that 22 is smaller than 120, I can go ahead and say, I know my legs are A and B. I have 22 inches and 120 inches, and I'm trying to find my hypotenuse. So my unknown is my hypotenuse. Now, if you need a picture, which sometimes I need a picture, you can go ahead and draw that. It's just a right triangle, but you have to make sure that the leg, you have one 22-inch leg and one 120-inch leg, and you know you're missing the hypotenuse, which is across from that right angle. So with that picture, you just set up a squared plus b squared equals c squared. You're going to let a be 22, b be 120. You square both of those. 22 squared is 484. 120 squared is 14,400. And that's going to be added up to equal c squared. We add those up. And then we take the square root of both sides. When you do the square root of 14,884 in your calculator, you get 122 as the measure of C. And that, of course, is 122 inches. The next step is to add up for the perimeter. A plus B plus C. So we take 22 plus 120 plus 122. 2 plus 2 is 4, carrier 1. 2 plus 2 plus 2 is 6, plus 1 is 7, and 1 plus 1 is 2. So 274 inches is our perimeter. Then, for the area, we want our base is 120, and our height is 22. So our area formula is 1/2 times base times height. 1/2 times 120 times 22. I'm going to plug that into my calculator. 1/2 times 20. Remember, 1/2 always has to go in parentheses. 1/2 times 120 times 22 gives us 1,320 square inches as my area. And the last warm-up problem, we're just going to go ahead and check and see whether or not they form a right triangle. And I've shown the work here for you so you can look at it at your own pace. So we have 21 is A, 28 is B, 35 is C. The longest side is always the hypotenuse. 18 is A, 80 is B, and 90 is C. So go ahead and check your work on that. Pause it if you need to, and then we're going to move on to notes. Today's notes are on whether or not you can use the converse of the Pythagorean Theorem and whether or not you can classify triangles using the Pythagorean Theorem. So first we have a definition. The converse of the Pythagorean Theorem states that whenever the sum of the squares of the two sides equal to the square of the third side of a triangle, the triangle is a right triangle. So whereas before we had, if we have a right triangle, then the Pythagorean Theorem is true, now we have, if the Pythagorean Theorem is true, then we have a right triangle. So it's the same exact thing, except for the fact that we have to have the Pythagorean Theorem true before we know we have a right triangle, instead of knowing we have a right triangle before we can use the Pythagorean Theorem. So if you need a second, make sure you pause it. Moving on. Okay, this is the next thing that's true. We can classify triangles using the Pythagorean theorem. Now, make sure you're taking note that we have our relation of sides and then our type of triangle. In all of the relations of sides, we have c squared first. C squared is less than, c squared is equal to, and c squared is greater than. In order for it to be acute, c squared must be less than. It makes sense. C squared is less than acute. Acute are less than 90. So if you think about c squared being less than, it's an easy way to remember it. C squared is equal to, you already know that's a right triangle. And then c squared is greater than. Obtuse means greater than 90. So you can kind of remember it that way. Now, the only thing that is kind of different is that you can also talk about it the other way, but you have to be careful. Okay, so this is the same as saying a squared plus b squared is greater than c squared. Okay, I like to write it with c squared first because if you have less than, you can think about c squared being less than is acute. Okay, now if you read what this says, if you look at just the c squared and read it backwards, you still have c squared as less than. But you have to be careful. So if c squared is first, you can have less than. But if a squared plus b squared comes first, a squared plus b squared is greater than c squared in order for it to be acute. Same thing goes with c squared is equal to. That's the same as a squared plus b squared is equal to c squared. But there again, we just like to put c squared first because it helps us remember what acute, right, and obtuse are. So if c squared is less than, it's acute. If c squared is equal, then it's right. And last, c squared is greater than a squared plus b squared. That's the same thing as a squared plus b squared is less than c squared. Okay? It's the same exact thing, but if we read it backwards, c squared is still going to be greater than a squared plus b squared, because remember the alligator eats what's bigger. So c squared is bigger if it's obtuse, and c squared is less if it's acute. So c squared is bigger than if it's obtuse. So let's go ahead and take a couple of examples. This does not have anything in the corner, so we do not know. There is not a little box in the corner that says it's right. Okay, so we don't know whether or not it's right. So we have to use the Pythagorean theorem, plug it in to see if it's a right triangle or not. So I'm going to label my sides from least to greatest. A is the least, B is in the middle, C is the greatest, and I'm going to check and see whether or not it's a right triangle. So I'm going to say a squared plus b squared equals c squared, or, like I said before, it's better to put c squared first. We're going to say c squared has what relationship with a squared plus b squared. Now remember, if c squared is equal to, then it's right. If c squared is less than, it's acute. And if c squared is greater than, it's obtuse. So, go ahead and plug it in. 15 squared has what relationship to 9 squared plus 12 squared? And I can just go ahead and put that in my calculator to see what it is. Now, it's important that you write it out like this. But after you've written it out, you can put it in your calculator. So, first step is 15 squared. That's 225. And my second step is 9 squared plus 12 squared. That gives us 225. What relationship do they have? Well, they're equal. So I have a right triangle. Okay. If it was less than, it would have been an acute triangle, and if it was greater than, it would have been an obtuse triangle. Let's go on to the next example. This one's a little different. 2 square roots of 39. I'm not sure what integer that's near. So I'm going to put that in my calculator so that I can see what integer that's near. 2 square roots of 39. So 2 square roots of 39 is equal to about 12.49, 12.5. So my smallest is 10, the one in the middle is 12.5, and the largest is 16. So I'm going to check. C squared has what relationship to A squared plus B squared? Remember, if C squared is equal, then it's right. C squared is less than, it's acute. And C squared is greater than, it's obtuse. And I just plug in my numbers. So I have 16 squared has what relationship to 10 squared plus 2 square roots of 39 squared. I did not use this 12.5. You have to use the 2 square roots of 39. So I'm going to put it in my calculator. 16 squared is 256. And I want to have what relationship. And then this part is tricky. 10 squared is normal. We do 10 squared like we always do 10 squared. Then we put it in the calculator just like it looks on the projector on the screen. So we open parentheses, 2 second square root. So if you notice here, I have 2 sets of open parentheses. So I'm taking the square root of 39. I close the parentheses. So these 2 parentheses go together. Then I have to close the parentheses again, and these 2 sets of parentheses go together. If you don't close off the parentheses for both open parentheses, it's not going to work. And then you square it. Press enter. You should get 256. So 256 has what relationship with 256? They're equal. So I have a right triangle. Moving right along to example 3. Again, pause it if you need to. Tell whether the triangle is a right triangle. So same steps. My smallest side is 32, then 39, then 48. We want to see what relationship C squared has to A squared plus B squared. Keep in mind, C squared has to be equal for it to be a right triangle. C squared has to be greater than for it to be an obtuse. And C squared has to be less than for it to be an acute. So, C is 48.5. I'm getting ahead of myself. And I want to have what relationship to 32.5 squared plus 39 squared. Again, all you have to do is put it in the calculator, but it is necessary to write out this step. So, 48.5 squared gives me 2,352.25. And I want to know what relationship that has to 32.5 squared plus 39 squared. So that's 2,577.25. So C squared, 2352.25, is actually less than 2577.25. So I'm dealing with an acute triangle. Example 4. Determine if the triangle with the following side lengths is acute, right, or obtuse. A is always the smallest, B is the one in the middle, and C is always the longest. We want to know what relationship C squared has to A squared plus B squared. Remember, C squared equals, it's right. C squared is less than, it's acute. And C squared is greater than, it's obtuse. So, all we do is plug it in. C, 41. A is 9. And B is 40. You must write this step out before you plug it into your calculator. It is important. So, we have 41 squared has what relationship to 9 squared plus 40 squared? So I didn't hit the squared button. 41 squared is 1681, and 9 squared plus 40 squared is 1681. They are equal, So I have a right triangle. Moving to the last example. I think the last example. No, we got two more examples. Example 5. Determine if a triangle with the following side lengths is acute, right, or obtuse. Same steps. A, B, and C. C squared has what relationship to A squared plus B squared? Remember, C squared is equal, then it's right. C squared is greater than, it's obtuse. And C squared is less than, it's acute. So, C is 8. 8 squared has what relationship to? A is 6. 6 squared plus B is 7. 7 squared. This step is just as important as plugging it into the calculator. Hopefully we all know that 8 squared is 64. Okay, 6 squared is 36 plus 7 squared is 49. 36 plus 49 is 85. So we have 64 has what relationship to 85? 64 is smaller than 85. So that means we're talking about less than. If we have less than, that means we are dealing with an acute triangle. Last example. Determine if the triangle is acute, right, or obtuse. Our smallest side length is A. Our middle side length is B. Our largest side length is C. We want to know what relationship C squared has to A squared plus B squared. So, if C squared is equal to, that means it's right. If C squared is less than, that means it's acute. If C squared is greater than, that means it's obtuse. C is 16. A is 9. And B is 12. This step is just as important as plugging it into the calculator. 16 squared is 256. 9 squared is 81. And 12 squared is 144. So we're going to see what 81 plus 144 is, and it's 225. 256 is bigger than 225, so we are dealing with an obtuse, if I can spell, triangle, because C squared is bigger than. Okay, that is it for today. So your homework is to complete the worksheet that's attached online or that you got in class. If you have any questions, feel free to rewind the video and pause on a problem you had questions about, or to email me.